Okay, this is COMG 302 Research Methods, Special Topics on Research Ethics. This is Module 11, and we are going to talk about the replicability crisis. This topic and the next few topics are about the dark side of academia. People tend to think that academia is a pure place. It turns out that it is not. It never was, and probably it never will be. But it's no worse, I think, than other domains of our lives, such as the corporate world or the government. I think the key is to, instead of avoiding the problems, in our case, all the ethical concerns or even violations, we should confront those problems to ask the question of, for example, what are the problems, where the problems lie, and what are the possible solutions. So only by taking this proactive approach can we possibly solve at least some of the problems and make academia in general a purer place than before. Okay, so this is the motive and the larger background for this topic and the topics in the next few classes. So the reason that science in general would have a replicability crisis, ironically, is because people try to do good science. But it turns out that when you ask people what good science is, you might have at least two answers. That is, people would answer your question, what good science is, from at least two perspectives. The first one is a methodological perspective. And people will say, from this perspective, good science is to obtain findings from correctly analyzing good data. And of course, you might ask the question, okay, then what do you mean by good data? And that really is a complicated question. But for now, let's just say good data are data collected following all the procedures we talked about in previous weeks, and data that are not contaminated, and data that are objective and valid. Okay, so let's use that as a working definition of good data. So this is one perspective to look at the question what good science is, and a second equally important and I would say to a certain extent valid perspective is an evaluative perspective. According to this perspective, good science refers to those findings or conclusions published in very important or prestigious academic journals. Ideally, researchers should uphold or should approach good science from this perspective. But you might see why this perspective is so prevalent and important in academia today. So ideally, these two perspectives should indeed agree with each other. That is, if you have a piece of finding that is based on good and sound methodology, then this piece of finding should be published in good journals. And vice versa, that is, if you see good finding published in good journals, then this finding should be methodologically sound and good. However, reality is always not that perfect. In fact, the two perspectives often contrast each other. What do you mean? That is, for many reasons, good journals are reluctant to publish findings that are based on good methodology, but findings that are deemed or considered uninteresting. And it's easy actually to understand why this is the case, because first of all, there are lots of researchers not only in this country but around the world. And all those researchers, professors, faculty are trying to publish papers in a handful of good journals. There are also many journals, but there are only a handful of good journals. And people are motivated for many reasons to publish the findings in good journals. And of course, the good journals are going to select what findings they think should be publishable. For many reasons, good journals are not interested in findings such as men in general are taller than women. They want findings that are counterintuitive. They want findings that are going to catch the attention from the press. They want findings that are eye-catching so that the impact of those journals will increase. However, interesting, attention-grabbing findings or findings that are counterintuitive are very difficult to be obtained when we apply rigorous methods. Rigorous methods means, for example, using very large sample size, use the appropriate statistical techniques to analyze those findings, and following all the procedures we talked about in previous classes, and many other procedures that you only learn about in more advanced class. Now here's the problem. So for junior scholars were people who just graduated from grad school and start their career in universities. They need many good publications in order to receive tenure. And that has actually usually a deadline, usually within 5 years or 6 years. So if you don't publish many good publications or papers, you'll be fired. At the same time, senior scholars also need many good publications, and they do so for a slightly different but equally strong motive, that is to secure research findings and to receive further promotions from associate professor to full professor and to dean and to chancellor and president of the university. So if scholars need eye-catching, attention-grabbing findings to have good publications in order to be promoted, but at the same time those findings are difficult to be obtained using rigorous methods, especially within a timely fashion or by a certain deadline, then you can easily imagine what those professors and scholars and researchers will do, that at least some of them will start to loosen the methodological standards. They are going to apply sloppy methods. So when they use those sloppy methods to find an eye-catching findings and published finding in good journals, but because the finding is obtained using less than good or even very bad methods, that finding is not going to be replicated. That is, the finding is not going to be observed again by other scholars who are interested in the same topic. So eventually you will see, and you can imagine, as these practice goes on, that is to publish eye-catching findings based on subpar methods, and those findings are not going to be replicated, then good journals are going to be filled with findings that are likely not true. That is, findings that will appear positives, but actually they're false. So those are false positive findings. And this leads to the replicability crisis. That is, findings published in good journals and many less than good journals cannot be replicated, cannot be reproduced, and any finding that cannot be replicated independently by other scholars cannot be trusted. And then if journals are filled with false positive findings, then you can imagine that the whole discipline is going to be misformed, because people are going to spend time following up those false positive findings and they're going to find nothing. and the entire discipline will be misled. And that, you can see, is a serious problem. Just to illustrate this problem, a bunch of scholars, they conducted 2 studies to demonstrate how easy it is to produce eye-catching findings, but findings that are logically impossible. So the first study is on how listening to certain musics would make people feel different subjective ages. So they recruited 30 college students from the University of Pennsylvania, and those students either listened to a control song, Kalimba. This is a song that comes with Windows 7 operating system, or a children's song, Hot Potato. And we can listen to a snippet of both. And so 15 participants listened to this song, and
hot potato, hot potato, hot potato, hot potato.
The remaining 15 listened to this song. So from previous class, we know that this is a classic between subject design, right? Some participants received one treatment, other participants received another treatment. So after listening to these 2 songs, participants will ask the question, how old do you feel right now? And they answer this question using the scale from 1 to 5, 1 indicating very young, 5 indicating very old. So this measures their subjective age. And participants also provide their father's age, and this to control for differences in baseline age. Not all participants are going to have the same age. And the findings this. So this is the Kalimba group, this is the hot potato group, and this is participants' self-reported age, or their subjective feeling of being old. As expected, participants listening to hot potato songs, they indicated that they're feeling older than participants who listen to Kalimba song, and this difference is statistically significant. That is, it appears to be true. And then they follow this study up with a second study that's implausible or impossible. That is, listen to certain music will actually make people younger. So they recruited 20 college students. Half of the students listened to Kalimba, again the control song, and the other half, that is the other 10 students, listened to Beatles' I'm 64. So we can listen to a snippet of it. Okay, so after listening to these songs, participants asked, what is your date of birth? And that's to measure, of course, the actual age. And then, of course, similar to study 1, participants were also asked to provide their father's age to control for the differences in participants' baseline age. Anyway, so here's the finding. Participants listened to either the Kalimba song, or when I'm 64, they reported their actual age. And look at this. Participants in the condition where they listen to the song when I'm 64, they're younger by by a little bit more than 1 age than participants listen to the Kalimba song. So it appears to suggest that listening to different songs might cause people to be older or younger. That's a very cool finding, but this finding cannot be true. Logically, listening to music cannot make you younger or older. So here's the problem, right? So the 2 studies were conducted with real subjects. So the 2 studies actually happened. And all the statistical analyses were legit and appropriate. So the conclusion of the first study that listening to certain sounds might make you feel older, that might be possible. It could happen. But a finding of the second study, that is listening to certain sounds, will cause listeners to be younger or older, that simply cannot be happening, at least in this world. But yet, these, the Simmons and colleagues demonstrated this impossible finding in the lab using real participants and legit statistical analyses methods. Um, there are many problems with the design, and many of the problems, we're not going to talk about here because those problems are very technical. But a major problem is that the sample size is too small. The first study used 30 participants, and the second study used 20 participants. Those samples are simply too small, and the problem with small samples is they produce extreme values, leading to the appearance of larger contrast between the conditions than the contrasts actually are. In fact, when researchers try to replicate those two studies using much larger samples, expectedly they were not able to replicate those findings because those findings simply are not true, and this one is not impossible. So that's simply so. This is this is a demonstration of the replicability crisis, right? The inability to replicate findings produced in the lab. And there are many causes of the crisis, or many layers of the crisis, causes of the crisis. The first one is the whole policy of publish or perish, right? You either publish good papers or you are fired. So that will be pressure from the institutions. So scholars are under pressure to try very hard and sometimes do whatever they can to get good findings. The second cause is from the discipline, such as social psychology and biology, to emphasize novel and perfect findings. They expect the authors, the researchers, to submit findings that are clean, not noisy, and yield very apparent patterns, and patterns that are counterintuitive and eye-catching. So that's pressure from the discipline. The third cause is with the journals, editors. They're also professors and faculty. They're very busy, so sometimes, and reviewers, they're faculty too. So they're very busy, so they might be not stringent enough when they review others' work. So that's the problem that exists at the level of the journals. And lastly, though, and equally important, is researchers' their own fault that they don't conduct studies while holding themselves to high standards. And in the next module, we're going to talk about some specific examples of misconduct in conducting or reporting findings. So all these findings, all these reasons collectively result in the replicability crisis. So it's not one single person's fault. It is indeed a collective crisis that needs to be solved. So fortunately, many disciplines are now taking action to solve the replicability crisis to save the entire field, such as now journals, even good journals, they don't expect novel or perfect data. They accept noisy data because the world is noisy. And many good journals, they're applying more stringent, more strict reviewing criteria. And many good journals, they enforce what is called open data practices. That is, if you want your paper to be published, you must also submit your data so that other people can check your data and try to replicate your findings with your data. Lastly, many researchers, they're reviewing many of the methodologies that have been taught in graduate schools or in undergraduate classes, so to replace flawed methodologies with more appropriate methodologies. So I think, and many others agree with me too, that we should not lose hope. There are, of course, problems, right? Nothing's perfect. Academia certainly has its own flaws, but we should still have hope because people are actively taking actions to solve those problems. And we, either as students of social sciences or as practitioners of social sciences, should collectively do good to the field. So, to make our field flourishing and worthy of people's attention and money. Okay, we'll resume next time to talk about some examples of bad practices in reporting and analyzing data. See you next time.